Hi, welcome everybody. Good morning or good afternoon, depending on where you're watching from. My name is David Corvala, and I'm a staffing coordinator here at Encora, Mexico. And today I will be your host. In today's session, we will discuss how a traditional application development approach differs from a modern microservices approach with focus on serverless security. We will discuss key concepts such as AWS shared responsibility model, the principle of least privilege, defense and depth concepts, and how to secure your serverless workload using the appropriate AWS services. And today's session will actually be led by Hamdy, our senior partner solution architect at Amazon. Just a reminder that you can follow us on all our social media that will be appearing over here on the screen. And this session is a part of the Global Devweek organized by Encora. And one final reminder before I hand off the mic over to Hamdy. Remember that you can use the chat to leave any comments or questions or anything that has been interesting to you throughout the session. All right, so thank you very much for taking the time out of your day here, Amdi, to share
Of course.
your knowledge with us. I'll go ahead and leave the stage to you.
Thank you. Hi. Hello, everyone. And I'm here to talk to you about serverless security. So let's get started. All right. So today we're going to be discussing serverless security and how to architect secure applications on AWS. Our agenda for the day is as follows. In order to understand how security is different for serverless applications, we are going to look first at what the traditional development environment looks like and how is it different from a serverless mindset, if you will, or modern developments such as microservices, containers, or serverless. And in doing so, we are going to talk about certain key tenets or concepts. Uh, we're going to talk about the AWS shared responsibility model. We're going to talk about how to grant least privilege and how to implement defense in depth, which is really important to do that across all layers of your workload. And we're going to close up with some AWS security best practices. So without any further ado, let's get started. So this probably is not a new slide to you. This is a traditional three-tier web application architecture that we all are used to, which consists of three layers. Web server as your presentation layer. You got your application server, which is the business logic layer. And then you got your data store or data layer, that's your database servers. Now, this architecture, is it workable? The short answer is yes. This is actually a workable, very workable architecture, and we still see some of our customer at AWS using that, deploying the kind of architecture on EC2 instances. However, this has certain limitations. For example, this is a monolithic way of thinking. It's a monolithic application, meaning all layers are tied together. They are um, tightly integrated together. So you have a lot of tight coupling going on here between the layers. If you were to change one of the layers, let's say the web servers, then that will have a ripple effect uh, across other layers as well. It's not easy to scale because you're not using separate building blocks. It's all one piece, or have a certain level of high availability. So with that in mind, let's see how this is different from a modern application development. And then we're going to dig into security aspects of it. First and foremost, when I say talk about modern application design, I'm talking specifically about things like serverless and containers, and how do you have that serverless mindset, if you will. Again, there are five key tenets that distinguish traditional development mindset from a serverless first mindset. The first one is what we call features first. And what that means is modern applications or serverless applications tend to be composed of or be a federation of features and functions. Each feature or function does a specific job, and so the application itself is broken down into small pieces, and that follows the principle you avoid this monolithic thinking. Obviously, and components can scale and fail independently. The second tenet is focus on events. Events could be anything, like for example, push over IoT button push is an event. message arriving at a queue is an event. AWS is a very rich ecosystem of events. So event is at the heart of serverless mindset because it is what triggers your workload. The third tenant is stateless. Now, in traditional application development, I see in the previous slide, you typically keep track of the state of your application, like a session state, for example. So that's hard, sometimes hard concept to grasp for some people who come from that traditional kind of environment because where does the state go, right? So in serverless, the state still goes into could be list caching layer. It could go typically you go into DynamoDB, which is our NoSQL database, to maintain the state there. The fourth layer is the data flow, and the data flow is really important because you're going to start thinking about what kind of data types you have in your workload, how they have structured data, non-structured data, documents, and understanding how your data flow is going to flow, start to enter the application. Sorry, excuse me. Then you can decide which kind of data store you want to pick, right? SQL versus NoSQL database, for example, or a GraphQL database. And the last tenant is use the service, meaning use the AWS service will provide a lot of managed services, and then you have serverless and container. Don't reinvent the wheel by creating something custom. Again, so let's talk about that from a security standpoint. So we just said uh, features first, meaning the application is composed. First thing you notice about serverless or microservices architecture is the so many icons use typical those architectures because they are individual components. So there are key differences here. The first one is what we call they are ephemeral services, meaning those services tend to do something specific and then they go away. They tend not to stick around. Like for example, a lambda function. You can use the lambda function to access DynamoDB, get the data, and then the lambda function is gone because it's a shared service. Um, and the second thing is about security here in the serverless world is it has a diffuse parameter. A diffuse parameter again goes back to the fact that those individual services, for example, you see Lambda API Gateway, DynamoDB on the screen, those services, each one of them have its own set of configuration, right? Security configuration. So you can configure security for those services separately. The third difference is tooling. Tooling is different for serverless application. We need to use SAM, and I'll talk more about that. Serverless application model and CDK, Cloud Development Kit, and these also support definitely all the features that you need for security. So the question comes, what kind of security does not change? Well, IAM, Identity and Access Management, that is the glue. That's the main services that you use, as you see in next slides, to define security roles and permissions and so on. What also doesn't change is securing your data. You're still responsible for securing your data, and you're still responsible for writing quality code. With that in mind, so we have developed something at the AWS a long time ago called AWS Shared Responsibility Model. Basically, security is a shared responsibility between user, customer, and AWS. So what does that look like? Well, first, you look at an infrastructure view here of the shared responsibility model. In a nutshell, AWS is responsible for security of the cloud. So we're responsible, for example, for securing our physical facilities, our data centers, our edge locations, and then we're also, of course, including hardware, and we are responsible for securing the core services like compute, storage, database, and networking. Now, you, the customer, are going to build on top of that, right? So you're going to build applications. The application is going to have data. So you're responsible for security in the cloud. Things like customer, your data, you have security data, you have to encrypt them, you have to use our security services, like for example, IAM for identity and access management, and you have to secure networks and so on. So does that model change in a serverless world? And the short answer is yes, it does. So this is how it looks like in a serverless world. The line in the middle switches up north, meaning most of the serverless services we have at AWS are what we call managed services. And that includes things like Lambda API gateway, SQS for queuing, SNS for publishing for notifications, step function for workflow, orchestration, and so on. So when you use those managed services, AWS takes on more responsibility, okay, than the customer. So start securing the compute, Lambda compute, for example, or our containers, AKS. We're responsible for the secure the execution environment, like Firecracker. We're responsible for the runtime. Lambda supports multiple runtimes, and also the network infrastructure as well. So that does change with serverless. Security does change. The line shifts up. Um, Now we'll discuss a very important concept called least privilege. And the least privilege is very basic, but again, it's a very core concept when it comes to serverless security. What does it mean to grant least privilege? Well, it means that you're only granting the essential privileges needed to perform the intended work. However, it's a principal, an individual user, a user group, or an application. And you do that by attaching an IAM execution role to the service. Each service in AWS does require an execution role, right? Basic execution role, and those roles use same permissions. We highly recommend using unique roles per function or per service, as well as assigning fine-grained permissions in the policy. What you see on the right-hand side, for example, is an example of an IAM policy, right? In which you putting trace segments, right, for X-ray, which is our and I'll talk more about that. Our security service, our tracing service for security distributed applications, and we are seeing resources asterisks effect allow, meaning we allow all actions in all resources, right? When you put in traces or you put in telemetry records. So some policies will have an asterisk to indicate that, but you should always look at the IAM policy and evaluate it according to your security and compliance requirement. So be specific, identify those limited set of security. It's always better to start with a small set of permissions and then expand than the other way around, than giving being too permissive and then trying to curtail it back. Scrutinize the use of asterisks in any policy, even our own policies. Sometimes it's appropriate, like when we're doing tracing. Sometimes it's not appropriate if you are accessing a database, for example. I talked about SAM very briefly. I said with serverless security, tooling changes, right? So SAM is a shorthand, basically. It's an open source framework that you use to deploy your serverless application, right? So you create, helps you create the resources, any of the AWS serverless resources that we offer. There's three here: API Gateway, or API Service, Lambda, and DynamoDB. Just an example. And SAM is, think of it, if you are familiar with AWS Cloud Formation. Cloud Formation is our infrastructure as code service, and allows you to, again, to create resources and deploy them in a secure manner to AWS. SAM is think of it as a SAM macro that sits on top of Cloud Formation. So when you run the SAM template, it will get expanded eventually or exploded into a Cloud Formation template. For example, on the left-hand side, you see that's a SAM definition for a Lambda function. So we start by explaining the type of the function as AWS serverless function. We have the handler to the Lambda function, what the runtime is, but what's being highlighted is the policies, right? The security policies. So for serverless specifically, we have wrote about 50 plus policies for our customers they can just use, okay, without any modifications. One of them is DynamoDB write policy, for example, right? And you all have to just reference the DynamoDB table within your SAM template. And what that is, what's it done on the cover for you is what you see on the right hand side. So it allows you to do, for example, put item, update item, batch write item, and then provide the resource they are in, the Amazon resource name, which is the link, basically, the Amazon resource name for the DynamoDB database. You can also control access with IAM. As I said before, IAM, or Identity and Access Management, is a very, very important service when it comes to server security and security in general with AWS, because it allows you to provide permissions based to authorize access to either the control plane or the data plane. All right. And as you know, control planes are actions that manage, creation of resources, like creating a function, or create and updating a state machine, or creating a service bus. Data plane are things that you do daily, every day, like invoking a function, right? Or putting a message in the queue, and so on. Now, IAM is very involved service, and we're not going to cover everything, but it does. But what I want to say about it is, remember, in IAM, the golden rule is deny, allow, deny. So in the IAM policy, we deny everything by default, okay? Unless you explicitly allow it. But IAM principal policies or identity policies that belong to users and groups are not the only option here. We also have resource policies, things that apply at the resource level, like for example, an S3 bucket, right? That is a resource level that can have its own resource policy that controls who can access the bucket. It also controls if the bucket is accessible across different AWS accounts and so on. We also have VPC endpoints, and that's very helpful when you try to, for example, access a public service, a serverless service securely that's sitting in our public zone, like DynamoDB. So you're trying to have access DynamoDB, in the public zone. Then you see you from using your network from your VPC. VPC stands for Virtual Private Cloud, which is basically your network and subnets. You can define an endpoint and have an endpoint policy on it to control security that way. And the last one I want to talk about is SCP, or Service Control Policy. And when you do serverless or any kind of development in AWS, as from a security perspective, especially if you're running into a multi-account environment, and most customers do, we use a service called AWS Organization, and AWS organizations have SCP, Service Control Policy. Service control policies do not grant permissions, any permissions to the resources, but they act as filters at the account level. So you can use, for example, an SCP policy to say, well, only users can only spin up an EC2 that have 16, gigabyte of RAM. Anything above that is not allowed. So they act as filters. What else can you do with IBM? Obviously, I'm sorry, with IAM. I already talked about resource policy, right? So you can use condition to scope those permissions. You can allow cross access, account access. Each service in AWS in the serverless security realm, it needs an execution role, a basic execution role. So in the example you see here is two accounts, account A and account B. Now in account A, we have an event bus running, and we have another one as well in account B. And account A is publishing events, right? It's creating objects and publishing it to another bus on account B. And to do that, you need a resource policy, IAM resource policy. Once the events are there, then you can define rules on that event bus in account B, and those rules will have targets. A target can be a container, can be a Lambda function, can be an API gateway, can be a step function, and so on. And when the event bus in account B start to invoke the Lambda functions, they will need an execution role. And that's very important concept, because this way, at each layer, you can apply security. Now, let's talk a little bit about defense in depth. What does that mean? When we say defense in depth, what we really mean is talk about common vectors of attack. Meaning, at AWS, we strongly believe that security is job zero for us. Meaning, we are include security, inject security at every layer of the application. So, defense in depth means you are reducing your blast radius, basically. You are controlling how far an attack can go into your network by having those guardrails in place. For example, from an application point of view, there are certain things that you need to protect against, like SQL injection, cross-site scripting, and so on, and common web vulnerabilities, basically. But your code also have dependencies, right? If you're using Node.js, I'm sure there's a lot of libraries that goes with that. Your base images for containers. Also, when networking, you need to think about network segmentation, breaking the network into subnets, and running a route table correctly, creating a security group correctly, and designing the permissions security groups. You might also want to actually protect the network as a subnet level. by defining what we call NACL, Network Access Control lists, which are stateful firewalls. And I'll talk about some of those services briefly. So this is an example of how you practice defense in depth. So again, what it means is you're implementing basically multiple redundant measures across systems or services. This way you can address common vector attacks. You can leverage AWS managed services, obviously like WAF, Secret Manager, and so on. You should also consider other features like backup and encryption using RKMS. So this example for when a request comes from the internet or from the user for your application, which is in the previous slide, there are certain common attacks like SQL injection and cross-site scripting. For that, we use WAF, right? Web application firewall. And WAF you can use WAF by itself, or you can use it with a CDN, content delivery network, like CloudFront, for example, or Cloudflare. Could be a third-party one, right? And integrate WAF with it, right? And WAF will allow you to define rules. So again, it's all common vulnerabilities, basically, as well as custom rules as well. So you can block people based on geography, based on IP address range, and so on. And then if the request gets to the API call, let's assume it's an API call, it gets your API gateway, then API gateway have request validation, right? So you can turn it on. It also has throttling as well. So you can protect your service against all DDoS attacks. Every AWS account comes with AWS Shield, right? It's free service and it has a basic support for DDoS protection. But you can also opt for critical application to buy or purchase Shield Advanced, which gives you advanced feature protection against DDoS attacks, as well as 24-hour support from our DDoS team. Then we start with the request finally gets the backend, like Lambda or a container for your task. Then use IAM, obviously, policies I explained before, the execution rules to control how the service are going to access the database or S3 bucket and so on. You should also encrypt your data using KMS or key management service. You can do the encryption at rest, also provide encryption in transit as well using AWS Certificate Manager and so on. So putting those security in place for a serverless application at those different layers, it does protect you in terms of you have greater chance the certain attack will not make it all the way to your backend. And that's what we mean by defense in depth. Another example for API gateway, for example, so you can do what we call offload authorization at the front door of your APIs, and we provide a few authorizers that you can use. You can use, obviously, JSON Web Token. You can use our Cognito user pool. By the way, Amazon Cognito is our user management service that allows you to provide authentication authorization to your web and mobile apps, and integrates with LDAP, Microsoft Active Directory, and it supports SAML authentication, and so on. But you can also have Lambda authorizer. That's a custom authorizer. Maybe you have an authorization server in-house, and you will write a custom authorizer. We provide that actually in GitHub that you can modify very easily and use that way. So that's for protecting your APIs. For protecting your network, as I mentioned before, so most of those public serverless security, most of our serverless services run in our public zone, right? AWS public zone. But sometimes we see customers that say, well, I need to learn Lambda in a VPC, the virtual private cloud. So it's not a public zone, obviously. That's a private subnet because, for example, the workload or the application is not a publicly accessible application. It's a private enterprise application. And that's the valid use case. So to do that, obviously, we strongly recommend using AWS Network Firewall or something similar like F5, so you can control your ingress route traffic. To do that, you have a couple of you have to define your route tables. You have to define your VPC endpoints for how, for example, Lambda is going to access DynamoDB, things like that. You can if your Lambda needs access to the internet, they define a NAT gateway, network address translation, and put the appropriate security group in it to protect it, and so on. So each of those subnets, you will have a security group, and then you can also have network firewall rules at the subnet level. So the attacks will not even reach the instances. Now, there's pros and cons for that. Obviously, there is a cost associated with running the kind of a secure architecture, and there's also complexity because most serverless developers, they are not network people, so there's some learning curve for them. Now, we can't talk about serverless security without talking about log and monitoring. That's very important because why? Because in a serverless environment, again, you are in a distributed environment. Remember at the beginning of the presentation, I said there are independent components, right? Independent building blocks. Each one has its own security configuration. And as such, when those services, even though they can scale very well, they can fail and independently and scale independently. That makes it also complicated to trace it if something wrong happened across the way. And for that, we highly recommend X-Ray, AWS X-Ray. X-rays are serverless tracing services for distributed applications. It was built specifically for microservices. Okay, but we also have CloudWatch as well. Our CloudWatch is our flagship, logging and monitoring solution. If you guys, it's a very basic service that a lot of our customers use. So X-Ray, a combination of X-Ray and CloudWatch, and even CloudTrail, which logs every API call to your account, whether it's from the console or the command line or through API call. So that gives you visibility, which is really, really important for control. For example, X-Ray will create a service map. Let's say you have a Lambda function, right? The user comes through API gateway, and then API gateway is calling a Lambda function. A Lambda function is accessing data in DynamoDB. So X-Ray, when you enable X-Ray in your SAM template during deployment, it will create a service map for each component. And I'll show you that the next screen. And each component is going to have its own trace files. So you can know what's going on. For example, you're looking here. That's an example of ECS container, right? Running a storefront application. Okay, and when you turn on X-Ray, you go to CloudWatch cons and you click on Service Map, and then you can visually see your application. If you click on a component, on the first one, for example, it shows you, for example, this is executed in 19 milliseconds, right? The type of the container and so on, and what's calling and what the fault or error rates are, and you can click on each component and find out what's going wrong with it. When you click on a component, it displays the trace file on the bottom. You click on the trace file, and for example, you have a timeout in your API gateway or too many requests, like for HTTP error 429, you'll be able to easily troubleshoot that. So that does help a lot with security posture as well as, of course, performance improvement. Now, we'll talk a little bit quickly about AWS security best practices here. Use appropriate authentication and authorization mechanism. Again, use Amazon Cognito, for example, or Microsoft Active Directory. Use IAM. Use appropriate authorizers in your API gateway or your AppSync for GraphQL, and so on. Follow this privilege principle. Only give the permission that's needed and expand it from there. Store secrets securely. Okay. Now, I know some developers love to, hard code passwords in application code because it's easier that way. But we have a great service I haven't talked about called Amazon AWS Secret Manager. Okay. Another one called AWS Parameter Store. So these two services you can use to store your secrets, like your database, like the password to your database, for example, and you can retrieve those from your code dynamically at runtime. Okay, by providing the link or the ARN or the resource name towards the secret store. And Special Secret Manager, it stands out in the fact that actually has the capability to rotate your secrets every 90 days or on a schedule basically that is set. And it uses a Lambda function under the cover to do that. You should identify and classify your sensitive data in your data source, especially S3 or a SQL database. And if you dealing with PII data, for example, the sensitive data, you can use Amazon Mace on your S3 bucket. You should minimize storage of sensitive data to what you only need. And again, Amazon Mace is a good choice for flagging those data out in S3 buckets. You should protect your data at this using KMS, Key Management Service, as the key service to use, and in transit using, of course, SSL, as well as utilizing our certification manager. Here I'm leaving you with some resources. For example, these are did the first reInvent 2022 deep dive for current security system AWS and so on. I would highly recommend you read the AWS Work Architecture Framework Security Pillar. That's a very nice white paper. Okay, I won't read every single slide, but you get the idea. And here I'm giving you some access to some of the free training we have, like AWS Security Best Practices Overview. And also, if you want to do some hands-on labs, but some of the services I discussed today in terms of serverless, we have the well-architected security pillar, and we also have the well-architected security hands-on labs. So you go to the link, you'll be able to do some hands-on as well. With that, I would like to thank you very much for your time today. I hope this was educational, and it's been a pleasure talking to you. Thank you. Have a good day.
Thank you very much, Hamdi. Thank you so much for this great session. I'm by no means an expert at all, of course, in cloud architecture, but I think this was a great intro into understanding, how we can use such a innovative and honestly quite a workload reducing solution here. So thank you very much for this session. I really appreciate your time here.
My
And
pleasure. My pleasure. My pleasure. It's been my pleasure. Thank you.
thank you very much. And again, a quick reminder to the audience that any questions or comments, we want to see some discussion be sparked there in the chat that you can share, with others in the session, or questions that we could share here with Hamdi. We would love to see that in the chat. And well, Hamdi, thank you again very much for your time. We hope to see you again in future editions here of our global Dev Week here at Encora.
Thank you,
And
guys. Have fun at the conference, and talk to you soon. Thank you. Bye.
awesome, thank you. And again, thank you as well to the audience of the people that are here watching this session. Morning, afternoon, as I was mentioning, this is a global event. Just a quick reminder that the next session should be starting soon. Remember to return back to our official website to see the agenda and see where you can watch the next session here at the Global Dev Week. Again, thank you everybody for your time, and have a wonderful rest of your day.